Now the next thing that I want to talk about is section 10.5. So you can see we finished section 10.4 earlier, and now in section 10.5 we are going to talk about multiplying and dividing rational expressions. So we'll start with how to multiply radical expressions. With radical expressions, you basically just FOIL your two expressions that you're trying to multiply, just like how you would do with any binomial expression. You do the same thing with radical binomial expressions. So we have our first example here. A square root of 3 minus 5 is being multiplied with the quantity square root of 3 plus 5. Now again, if you recognize this form, you can go ahead and apply the difference of squares idea here. Again, remember, difference of squares is basically something like this. Where you have a plus b, a minus b. Okay, you can see same numbers but different signs, and when you multiply them together you end up with a square minus b square. So that's the same thing here. You have your a minus b, you have your a plus b, and when you multiply them together you end up with a square minus b square. You can apply that same idea here, or if you just want to FOIL the two expressions and come up with the answer that way, go ahead and do it like that, and you will still end up with the same exact answer. So let's go ahead and we'll apply the difference of squares. And that will give us square root of 3 square minus 5 square. Again, remember, a square minus b square, so that's your a square minus your b square. And let's see what you end up with. 3 squared will basically, remember again, square and square root are inverses of each other, so you end up with 3 minus 5 square is 25, and that will give you negative 22 as your answer. So you can see by applying the formula here, you are saving yourself a lot of time and you come up with the answer more quickly. Let's go ahead and take a look at a couple more examples here. Let's say we have something of this form. Square root of 7 minus square root of 11, and we're multiplying this into the quantity 2 square root of 7 plus 3 square root of 11. Now here you can see that these two terms here are different from the first two here, so you cannot apply the difference of squares here. The only thing you can do is FOIL them. So let's go ahead and multiply these expressions and see what kind of answer we come up with. So we start by multiplying square root of 7 into 2 square root of 7. That's your first step. So you'll end up with 2 times square root of 7 square root of 7, which will be square root of 7 squared. Okay, so this times this will give us this, and then you'll end up with plus 3 times square root of 7 times square root of 11. So 3 times square root of 11 times square root of 7. Okay, so that's your two terms. Then you take the negative square root of 11 and multiply into 2 times square root of 7. So that will give you minus 2 square root of 7 times square root of 11. Okay, so those are your first three terms, the f, o, I, and we're left with the L, which is the last. Negative square root of 11 times 3 square root of 11, and I'm going to go ahead and write it here on the second line. Positive and negative will of course give us negative. 3 times square root of 11 times square root of 11. So again, basically you end up with 3 times the square root of 11. Okay, now let's go ahead and simplify what we have here. And let's see, again, square will cancel out the square root, and you will end up with 2 times 7. Okay, for your middle term, of course, you cannot combine the whole number with the radicals, but using our product rule, you can go ahead and combine the 11 and the 7 because they have the same index number on them, and so 11 times 7 will give you 77. Okay, same thing will happen on this term here. You have 2 on the outside, and then you can combine the square root of 7 and square root of 11, which will also give you square root of 77. And then for your last term, you will again see that the square cancels out the square root, and you are left with 3 times 11 on your last term. Alright, so 7 times 2 will give us 14. Just like we did with the addition and subtraction, you'll do the same thing here. You can see that you have square root of 77, square root of 77 here. So you can go ahead and combine the 3 and the 2, so that will give you 3 minus 2, square root of 77, just combining the two middle terms. And then your last term, of course, 3 times 11 is 33. So 14, middle term will be 3 minus 2 is 1. So basically square root of 77 minus 33. If you want, you can put that 1 in the front, but you don't have to. So 14 plus 1 square root of 77 minus 33. Again, you can combine the 14 and the negative 33, which will give you negative 19 plus square root of 77. And you can see you cannot take it any further from here because of course you cannot combine the radical with an integer. So you leave this and this will be your final answer. I want to look at one more example on multiplying radical expressions. So let's go ahead and take a look at this one here. And in this example, we're talking in terms of cube roots. Okay, so we have cube root of 3 minus 1, and we're multiplying that into the expression cube root of 9 plus cube root of 3 plus 1. And again, the only thing you can do here is multiply. So we'll again use the whole idea of FOIL here. We'll start with cube root of 3 and multiply it into all the 3 terms for the other side. So cube root of 3 times cube root of 9, that's our first step. Then cube root of 3 times cube root of 3. Okay, then cube root of 3 times 1, which will be a positive cube root of 3. Okay, so that's with the first number. Now we'll go back and multiply negative 1 into each one of these in the second term, and that will give us negative cube root of 9. Okay, then negative 1 times cube root of 3 will give us negative cube root of 3, and positive 1 times negative 1, of course, gives us negative 1 as the answer. So I just basically continued the same problem down here on the second line. Now let's go ahead and simplify this, and you will end up with, again, product rule. You have the same index, so you can go ahead and multiply the numbers on the inside, which will give you 9 times 3 is 27. So you end up with cube root of 27. Same thing here, same index, so multiply the radicand. So 3 times 3 is 9, cube root of 9. This guy stays the same, cube root of 3. And these also here will stay the same. So cube root of 9 minus cube root of 3 minus 1. Alright, once we do that, now let's see, can we cancel anything out? Can we simplify anything further? So if you look at your first term, you have cube root of 27. Now 27 we know is a perfect cube because 3 to the third power will give us 27. So cube root of 27 is 3. You have cube root of 9, cube root of 9. So you can see these two terms are the same. One is positive, one is negative, which means that they cancel each other out. Same thing happens with cube root of 3. You have cube root of 3 positives here and a negative cube root of 3 here. So again, these two, positive and negative, will cancel each other out. So the first term we simplified it down to a 3. The middle terms got canceled, and then you're left with negative 1 at the end, and 3 minus 1 will give you 2. So you can see how this big long multiplication problem turned out into a simple answer. And this doesn't always happen, but in this example it did, and 2 will be your answer. So just break it down step by step, and you can go ahead and work on this.